Welcome to CyberNet Security. In today's video, we'll be talking about IP addressing. We have different type of IP addressing. We have the IPv4, we have the IPv6, and equally we'll be talking about subnet mask. We talk about the CIDR with the classless inter-domain routing and summary. So, what is actually an IP address? Like I said earlier, we have IPv4 addresses. IPv4 addresses are made up of 32 bits. um, which is divided into four parts. Each part comprises of okay, let me show you guys something. It has four parts, and each part comprises of 8 bits. That is 8 bits in one part, and these four different parts are being separated by a dot. They are being separated by a dot. So when you check 8 bits into 4, that's where you have 32 bits. That is why I said it's made up of 32 bits. So you have 8 bits, you have 8 bits, you have 8 bits, and you have 8 bits here. So when you see these bits are made up of ones and zeros. So if I have 1 here, 1 2 3 4 5 6 7 8 dots. I have another 1 here, 4 5 6 7 8. I have another 1 here, 1 2 3 4 5 6 7 8. Then I have 8 zeros here. So these 8 ones that are here is made up of make up 255 from 0, and this one is equally 255. This one is equally 255. This one is 0. Where these calculations are coming from is when you check this 1, this first one here, we call it it is 120. That was 128. This second one here, this 64. This one here, this 32. This one here, this 16. This one here, these 8. This 16. This one here, this 4. This one here, this 2. This one here, this 1. So how we got this 255 is from adding all these numbers here. When you add all these numbers, you have 255. So that's the same way we got this one, and that's the same way we got this one. So here now, it's the counting is from 0 to 255. So here now, no bits here is on. That is why we left it to be 0. So in IPv4 comprises of 4 different groups, like 4 different units, and each unit is 8 bits, 8 bits, 8 bits, 8 bits, which sums up to 32 bits addressing. So IP address is a unique identifier on the internet. Every device that connects to the internet makes use of an IP address. This IP address is what every device, your phones, your cameras, your laptops are being used to identify. These the addresses they use to communicate on the internet. These the address they use to send out messages. So your system, your computer uses an IP address, an IPv4 address, and equally an IPv6 address. IPv6 address is a comprises of 128 bits. As we move forward in this tutorial, we see an example of an IPv6 address. So let's go back to, so this is IPv4, this is IPv6. So IPv6 is let's move to IPv6. IPv6 is made up of 128 bits, like I said earlier, and IPv6 has up to 340 unidecillion type. Some people say is how do you get these numbers I'm mentioning? For example, if we have this is an example of an IPv4 address, 192.168.100.4. an example of an IPv4 address with the subnet mask of /24. So an IPv4 address has up to possibility of IP addresses that are on IPv4 2 raised to power 8, 16, and 32. 2 raised to power 32 is up to 4 point something million, 4.3 billion unique ones. Then for IPv6 is 2 raised to power, IPv6 is 2 raised to power 128, which is up to trillion. So you can imagine how big the network would be like. And the reason why this IPv6 came about is based on the people. We started to observe that due to the increasing number of computers that come into the networks, it will get to a time where IPv4 will deplete, and there won't be sufficient IPs to share to device. But recently IPv6 came to help grow, to help give us a better, will I just say, give us more rooms, give us a bigger room where we can accommodate more devices, no matter how much devices are coming to the network for the meantime. So this is the difference. That's why IPv4. But on networks these days, IPv4 still works. You can either use IPv4 and IPv6. You can use the two of them as well. So they do the same thing. So here we have IPv4 formats. Like I said earlier, we have the ones and zeros, and this is an example of an IPv4 address, which is 192.168.1.0/24, and this is the subnet mask 255.255.255.255.0. This IPv we'll come to this subnet masks as we move forward in this video. Subnet masks are used to we use subnet masks to further divide a network. We use subnet mask to identify which portion of the IP address is for the network and which portion is for the host. So when I mean network, I mean the number of subnets we can actually get from an IP address, and equally the number of devices that can be able to communicate, that we can actually use in a particular subnet. Some subnet that have, for example, /24 subnets, just like the one that we are seeing in the screen, 255.255.255.255, which is /24, has up to 254 possible host IPs that you can use for that subnet. So like I said before, this is an example of an IPv6 IP address. We have the area for the subnet ID. This one is basically for the host. This guy is used for this guy identifies the region. We have 5 region based on IR Internet Registry. We have 5 different regions. We have the IRENA and so many of them that take charge of several areas on that has to do with IP addressing. So this other one has to do with the area, like I said, that's for IPv6 IP addressing. So it's made up of like I said, 1 2 3 4 5 6 7 8 groups, just like IPv4 is made up of 4 groups. This guy is made up of 8 groups. Each group, each unit is made up of 16 bits. 16 bits hexadecimal. Understand? Hexadecimal. Hexadecimals are just like when you read from 1 to 15. If we have 00001 here, we have 0010, and so on and so forth to 15. So it's made up of hexadecimal numbers here. So let's move to the next one. So here now are different classes of an IP address. These are the different classes. We have the class A. We have the class A IP addresses, ranges from 0.0.0.0 to 127.255.255.255. Then class B IP addresses ranges from 128.0.0.0 to 191.255. Any IP address that you see ranging between these ranges, you can easily distinguish where this IP address fits in these classes of IP address. This actually works for class 4 subnetting. We have these days we do classlet interdomain variable length subnetting, where you can see an IP address that has 192.168 or dot something to /16, which /16 is for class B. But for classless inter-domain routing, you can actually see that you can actually, it gives you more room to further divide your network. It gives you more room to further manage the the number of the sizes of hosts that you want on a network, and they not equally maximize the number of size of networks that you have on an environment. So that's for class classful subnetting and classless subnetting. So let's go to the next one. So like I said earlier, in class A IP addressing, we have 256 total number of we have 256 total number of network that we can have on a class A IP address, and we have up to 16 million plus IP addressing for the host. And if you see this -2 here signifies in each in when you are doing subnetting, we have IP addresses. Two IP addresses are being brought out, which is the IP for the network, and the network. This is the ID address for the network, and the broadcast, So that is why these IP addresses are not assigned to any device on that subnet. So that is why we have to -2 from every possible host that you have on each of these classes. So in this class B, we have 65,536 possible networks that we can derive from this class B. Then the number of hosts that we can have in class B IP addressing is 65,536 -2, which is approximately 65,534 IP addressing. Class C, the same thing, 16 million. Class with the host is 256 -0 is 254, like I said earlier. Then the class D is used for mainly for multicasting. Multicasting is whereby you send a message to a group of computers, not actually every computer on the network, but you send a message to a certain group of computers, and when doing that, we use IP addresses that fall within this class D IP addressing. So class E IP addressing is for experimental purpose or any further future use. It's being reserved for future use cases, and so on and so forth. So like I said, any IP addresses that you see from this class D IP addresses are being used for multicasting. For example, if you see any IP addresses starting from 224.0, or like for example, I saw an IP address like this, 224.100, understand? So from with this first octet here, 224 here, I can tell that this is a multicast IP address. So that is where this class helps. So let's move on. So here we have subnetting. What a subnetting is, like I said earlier, I already talked about a little bit about subnetting. Subnet is just a way where the similar word is just a way whereby you break down networks into smaller chunks. It helps you identify which portion of the IP addresses is for the network and which portion of the IP addresses is for the host. Understand? So and it has the format still. It has the same format just like an IP address. It has the same format just like an IP address, made up of 32 bits. 32 bits. It has the same format like 32 bits and 255.255.255, which I said earlier. When you hear 255, you know that octet is all one. When you hear another 255, you know that octet is all one. When you hear 0, that means the octet is 0. That is what this guy means. And this thing here you are seeing here, if you count the ones that you have, you will see is up to 24. Then the 0 is 8, a number. That is why you see /24. And what it means is you have the opportunity, like I showed earlier, /24 we give you 16 million. We give you 16 million plus subnets. 16 million plus subnets. It will give you 16 million plus 16 million plus subnets. 16 million subnets. So the host will give you 256 -2 is 254 possible hosts on that network. So that is that. So let's go forward. That's for That's for subnetting. So it is used to identify which portion of the IP address, like I said earlier, is for the host and which portion is for the network. So and equally used for security purposes. Like I said, breaking down networks for segmentation, network segmentations is what is equally used for. So let's go to the next one. So the next one is classless interdomain routing. This is what I said earlier. Doesn't this actually doesn't follow the normal class 4 subnetting. This classless interdomain routing actually works like this. I can have a class B. That's like what an example that we have here. I can have a class B. Let me look for something to write with. I can have a class B IP address. Class B IP addresses IP addresses that range from I said is 128.0.0.0.0.0 to 191.255.255.255. So now this class BIP addresses. When you talk about the classless interdomain routing, which is the CIDR. So what happens here is I can take a class C IP address. A class C IP address is starting from 192. Understand? I can take a class C IP address like 192. This guy should be /16 for class 4 domain routing, for class 4 subnetting. So what if I have 192.168.100.0/16? Judging from this first octet here, you can see this is already a class C IP address because it doesn't fall in within this range of 128.0.0 to 195.255.255.255, and it falls in is on a default reference is 192. So it's not within this network, which is class B. So but when I have something like this, and this is equally 16, when I have something like this classless interdomain which is /16, what I mean here is the first 16 bits here is the network. But on a normal class 4 domain routing, on a normal class 4 subnetting, understand, in normal class 4 subnetting, this now 192 should be the first 3 is reserved for the network. But for a classless, the first two is reserved for a classless interdomain routing. In this particular situation which I have /16, the first 16 bits is for the network, then this last 16 is for the host. So if I have I can have, like for example, we have class A, I can have 10 class A, which is 10.0. I can have 10.0.0/24. This 10.0 falls into class A IP class 4 subnetting, but using a classless interdomain routing, I have 10.0.0.0/24, which means the first 24 bits in this IP address, if I should break down these stuffs to ones and zeros, we have something like 0 0 0 0 0 1 0 0 1 0 1. This for point 0 0 0.0.0.0.0.0.0. So this is all zeros, 8 zeros here, and this is equally 8 zeros. So this identifies the 10, this 0, this 0. So what I mean here is this area is set aside for the network with this /24, the first 24 bit, because when you count this 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 20 20 24, you should be up to 24. So the first 24 bits is set for the network, while the last remaining bits there is 8, which makes it 32 bits for an IP address, while the last 8 bits is set for the host devices. So that is just the difference between a classless interdomain routing and a class 4 subnetting. Class 4 subnetting, they maintain the block, that block form system of subnetting. But when you're talking about a classless interdomain routing or classless subnetting, where that's where you make use of a variable-less subnetting, you can see an IP address that looks like a class A IP address, but definitely is working as a class C IP addressing. So it gives network administrators, more manageability, understand, in managing their network efficiently. So okay. So in summary, we talked about the class 4. We talked about IP address in version 4 and version 6. Like I said, version 4 IP addresses have version 4 IP addresses have 32 bits, and version 6 IP addresses have 128 bits. And version 4 IP addresses are made up of 4 groups. Each group is made up of 8 bits, which is separated by a dot or a period. Version 6 IP addresses are made up of 8 groups, and each group is made up of 16 bits. And each group is made up of hexadecimal digits, which is up to 16 bits. So we have 8 groups, like I said, and from that groups we have the portion for the host devices. We have the portion for the subnet ID, and we have the portion for the regions, like I said earlier. So we talked about classless interdomain routing, like a variable length subnet mask. So where you break down subnets into smaller pieces, or you make subnetting more easier for you. So you don't use block of data, you don't waste free IP addresses on your network. That is where variable length subnetting helps you a lot. So I hope this video serves you guys. Thank you guys, and I hope to see you guys on the next video. Don't forget to like, subscribe, and share this video. Thank you guys, and do have a